everyone. In today's lesson, we're going to do more on area between curves. So in this example, again, feel free to pause the video and jot some stuff down before you listen to the explanation. But in this example, I want to find the area bounded by this line and this quadratic, and I want to round the answer to the nearest thousandth. So how this is different than yesterday is that these two graphs are actually going to intersect. So I don't give you a value of where to, find it between. There's no interval. So I basically want to find the area between these two curves. So this is the spot right here. The area between them is right here. Now in this example, it's very, very clear to see that they intersect at x equals -2 and up here at x equals 3. So that would be your top and your bottom. So, your A and your B. So if you have A and B and you do top minus bottom, it would be very clear that your A and B, your interval, would be from x is equal to -2 to about x is equal to +3. So when you do that, you would say -2 to 3. And then you can go ahead and put your top equation, but you have to see, is the line on top or is the parabola on top? Well, it's kind of clear here. This line is right on top, then the bottom, which is down here, is part of the curve. So the one that's on top is the line, and the one that's on bottom is the curve, or the quadratic. So my top is 3x plus 8. And my bottom is my quadratic, x squared plus 2x plus 2 dx. And you can go ahead, simplify that, and type it in. But there's something that we all have to understand. Calculus was a course that was designed before calculators. So how would a person figure out that it intersects here at -2 and over here at +3 without using the calculator? And the way that we would do it is we would solve and set them equal to each other. You want to know, when is this curve equal to this line? So what we would do is we would say, okay, let's take the curve, the x squared plus 2x plus 2, and set it equal to the line, and we can find where they intersect. So this is going to require a little bit of algebra. We're going to set it equal to 0. So -3x and -8. So we get x squared minus x minus 6 equals 0. And we're going to factor. Factor like usual. We're going to add to -1 and multiply to 6. So that should give us, if we do it quickly, x minus 3 and x plus 2. And this would be the root of 3 and a root of -2. So these values right here give us our A and our B. As far as the problem sets go, there is no way for me to tell if you got the x and y value, the x values by looking at the calculator. But on a Feedback Friday, I'm going to expect that you show me this work to find the intersections for the x values. Because again, calculus is that class that was made without a calculator. So let's figure out how we can finish solving this first. Let's distribute this. So we get 3x plus 8 minus x squared minus 2x minus 2. Put the x squared first. 3x minus 2x is 1x, and 8 minus 2 is +6. So this is what I want to integrate from -2 to 3 dx. So go ahead, type that into the calculator, get an answer, and then hit resume when you're ready for the answer. So I got approximately 20.833, and we can write units squared. Perfect. All right, let's try another one. So I wanted to go over a question like number 2 that included radicals because solving for the points of intersection is a little bit interesting. So obviously I want to find the area bounded by this curve and this curve. And the area between them, if we just want to shade it in, would be all of this stuff right in here. So I obviously can tell that I want to find the area. It's going to be bounded by this value of x equals 0 and this value all the way over here, which is x equals 9. So again, the formula is the interval over a to b of the top minus the bottom dx. So we know that it's from 0, so we can go ahead and do that, 0 to 9. The top equation here is my radical. So my radical is my top. And it's obvious that my line is straight, right? That's my bottom. So the radical would go on the top, so 1 plus rad x, and the bottom would be 1/3 x plus 1 dx. We're going to have to distribute this. So we get the integral from 0 to 9 of 1 plus rad x minus 1/3 x and then minus 1. You don't need those parentheses. I don't know why I have them, so I'm just going to erase them. And it looks like there's only a couple of like terms here, so this 1 and this -1 will cancel. So I want to integrate from 0 to 9 of rad x minus 1/3 x dx. It's not pretty, but it'll work. So go ahead, pause the video, and type this in and hit resume when you're ready for the answer. All right, I got approximately 4.500, rounding to the nearest thousand. So let's talk about that algebra of how I would get the 0 and the 9. Again, remember, calculus is an old course, so it was made before calculators. So we would set the left equal to the right, or the radical equal to the line. So I'm going to go ahead and do that down here. So the radical is 1 plus rad x equals the line 1/3 x plus 1. But what you notice is there's a fraction next to that x, and a nice algebraic trick to get rid of that fraction is to multiply both sides by the denominator, so that denominator of 3, and then distribute it in. So we have 3 plus 3 rad x equals 3 times 1/3, they cancel, so you just get x. 3 times 1, you get 3. So it's much easier to play with this now. So you have to remember from pre-calc or algebra 2 that when you solve a radical equation, you have to isolate that radical. So my goal is to get the radical by itself on that left side. So I'm going to minus the 3 on both sides. Lucky for me, they cancel. And I get 3 rad x equals x. Now at this point, when I say isolate the radical, you could divide both sides by 3, but then you're going to have a fraction on this right side, so I don't really want to do that. So what I can do is square both sides from here. So square this side and square this side. If I square x, obviously I get x squared. That's my right side. But when I square this, I have to square the 3 and then square the x. So 3 squared is 9. And then when I square radical x, you have to remember that the square and the square root cancel each other out, so I'm just left with x. So I have 9x equals x squared. And then a little algebra, we have to set it equal to 0, so I'm going to move the 9x over to where the x squared is. So I have 0 equals x squared minus 9x. And you want to go through all of your different factoring techniques. So if you notice, we could take out a GCF of x. I'm just going to write that work over here. So I have 0 equals x squared minus 9x. I'll take out a GCF of x, and I'm left with x minus 9. And if I do a quick little t-chart, we'll get x equals 0 and x equals 9. And that's it. That is our final answer. Okay, so here's another example. I'd actually like you guys to try this one on your own. And then hit resume when you're ready for the answer. Okay, so the first thing that you had to do was draw a picture to see which one was on the top and see which one was on the bottom. So if I have my picture here, my x squared minus 6, which I'll make in red, looks like this. This is my x squared minus 6. And then I will use blue for my 12 minus x squared. That one looks like this. It's just a sketch. So this is my y equals 12 minus x squared. So if you want to find the area bounded by these two curves, we want to find the area between here and here, right? That's the area between those two spaces. And it's obvious now that we've drawn the picture that this is my top and this one down here is my bottom. So this blue one is my top and this red one is my bottom. So again, if we want to find the integral, we have to do the top minus the bottom dx. So my top is 12 minus x squared, and my bottom is x squared minus 6. And I'm going to subtract them. So 12 minus x squared minus x squared plus 6. Negative x squared minus x squared is negative 2x squared. 12 plus 6 is 18. And I want to find the integral over some x values. So how do I find those? Some of you may have used the calculator to find those x values. My graph may be very off, and that's okay. But I'm just going to use algebra now to find those intersections. So 12 minus x squared equals x squared minus 6. And I'm going to move it over to one side. It doesn't matter which side, so I'll just go to the right. So I'll add x squared, and I'll minus 12. So I get 0 equals 2x squared minus 18. Take out a GCF of 2. I'll be left with x squared minus 9. I think I'll just move it over here. Factor more by dots. So x plus 3, x minus 3. And then my answers would be negative 3 and positive 3. So here must be our x value of negative 3. Here must be our x value of positive 3. So my bottom would be negative 3 and my top would be positive. So go ahead, pause the video, type that in, and hit resume when you're ready for the answer. Okay, I got a nice whole number of 72. So my area here was 72 units squared. Okay, let's try one more example together. I chose to do another radical because I think the algebra is a little confusing, so I wanted to make sure we were able to do that again. So first I'd like you to draw a picture of your situation and then hit resume when you're ready for the answer. Okay, so y equals 2x. That first one I'll draw here in red. Y equals 2x is just a straight line. And our square root is a little funny to see, but it looks like this, if you can exaggerate it a little bit. This is y equals x times x plus 1. So it's a little bit hard to see, but obviously my line here is my top. And the curve is the bottom. And I want to find the area between those two spots. So we're going to have to find the intersection, which I'll do over here. I'll do the algebra. So we have 2x equals x rad x plus 1. So this one's a little interesting because there's really no way to isolate this radical except for dividing by x, and it's not customary to divide by a variable. Usually you can divide by just numbers. So we're going to square both sides kind of like we did in the first example, just like this. So if I have to square 2x, I'm going to square the 2 and the x. So 2 squared is 4, and x squared is just x squared. So this would be 4x squared. And if I square this side over here, I square the x. So x squared is x squared. And I multiply it by rad x squared. So the square and the square root here will cancel each other out, and I'll be left with x plus 1. So we can distribute, and I get x to the third plus x squared equals 4x squared. And to solve that, we're going to set it equal to 0. So I'm going to minus the 4x squared with this x squared. And I get 0 equals x to the third minus 3x squared. And take out a GCF of x squared. And I'm left with x minus 3. Set each piece equal to 0. This would be 0, and this would be 3. So it looks like where they intersect over here is at x equals 3 and at x equals 0. So again, we're going to do 0 to 3 of my top equation, which we said was the line, so 2x, minus the bottom equation, which we said was our radical, so x, and then x plus 1, dx. Now, I know that this equation here looks really complicated, and there's probably no way that you're going to be able to combine like terms, and that's okay. You can just type this into the calculator just the way you see it. So why don't you try that now? Type all this in, and then hit resume when you're ready for the answer. And just a tip, you want to make sure you're using double parentheses, so this and this should be the open and end of the whole thing, and then make sure you have parentheses here and here. All right, so when I did it, I got 1.26 repeated. It doesn't clearly say what to round to, so we'll just leave it and we'll say that that's our area, units squared. It's a very small area. All right, that's it for today. If you have any questions, please let me know.